Welcome back. The app crashed, don't know why. So this is part 2 of Chemistry Chapter 3. We are talking about how to do word problems. Yay! Everybody loves them, right? Word problems and fractions. Woohoo! So I'm Miss Lisa. Welcome back, welcome back, welcome back. And make sure you go back and watch part 1. It'll make a whole lot more sense. And so what we're doing is problem number 5. And it is a problem, and I'll read it. It says, what is the volume? So we put V question mark of a pure silver coin that has a mass of 14 grams and has a density of 10.5 grams per centimeter. I didn't write the units, but you should. So first you write your knowns and unknowns, then you write your formula, density equals mass over volume, then you sing the song Substitute. So then right underneath D, write 10.5, right under M, write 14, and now we need to get V by itself. And the problem is it's in the denominator, so we're going to do the opposite. We're going to multiply both sides by V. These V's cancel out. And so we have V times 10.5 equals 14. And now we can say, why is V not alone? It's because it's being multiplied by 10.5. So we do the opposite. We divide by 10.5. This is really messy. And what you do to one side, you do to the other. So I rewrote it down here. 14, those cancel out. Whoop, it's more fun with sound effects. And 14 divided by 10.5 is 1.33. And that would be cubic centimeters. All right, so we just write our knowns and unknowns. We write our formula. We sing substitute. It's better with finger gestures too. And then you do the math. You keep doing the opposite. So make sure you read through these, and you can do them on your calculator too. Problem number 6 is a multi-step problem where you use conversion factors. So we are told we want to know how many seconds are in a day. Well, I don't know that, but what we do first is we write down what we know. And what I know is 1 day. And then I draw railroad tracks. The book has parentheses, but I have found in my decades of teaching, and we won't talk about how many, that kids will get messy with those parentheses, and they start making them look more like C's, and then they end up being 6's, and then they got the wrong answer. All right, so first you write down what you know, and then you write the unit of what you know down here in the denominator. So that's day. And then you write something you know that a day is equal to. And I know that a day is equal to 24 hours. So I'm going to put that down. And so 1 day equals 24 hours. My days cancel out. Boop, boop. And now I have hours, but I didn't want hours. I wanted seconds. Well, I don't know how many seconds are in an hour. I put hour in the denominator, and I put what I do know, minutes, in the numerator, because I know that there are 60 minutes in an hour. And now I can do it. I'm going to put minutes in the denominator and seconds in the numerator, and there's 60 seconds in 1 minute. Let me show you what I did. So the days cancel out, the hours cancel out, the minutes cancel out, and I'm left with seconds, because I know that 1 hour and 60 minutes is the same thing, and that 60 seconds in 1 minute. Any number on top I multiply, any number on bottom I divide, but you don't have to do ones, because anything multiplied or divided by 1 is that thing. So you do 1 times 24 times 60 times 60, and the answer is 86,400 seconds. Ta-da! We did it. All right, so our next problem is problem number 7. I'm going to erase this one. And this time, we are to convert, they want us to convert 0.073 centimeters to micrometers, which is this U-looking M thing. It looks like that. And if you didn't know the conversion, it was found in your book on page 40, but they tell us that 10 to the 6th power micrometers equal 1 meter in the problem. So that's a conversion factor. Now, I don't know. I'm going to have to do this in steps, because first I'm going to have to change centimeters to meters and then meters to micrometers. So I'm going to write centimeters on the bottom, because that's what I want to mark out, meters on top, and then I write the relationship. There's 100 centimeters in 1 meter. Ta-da! Centimeters cancel out. And now I write my new relationship. 1 meter is 10 to the 6 micrometers. Now, meters cancel out. Any number on top I multiply, any number on bottom I divide, and I end up with 730 micrometers. Now, your book did it in scientific notation unnecessarily. They do that, which I don't like, because people don't really understand what 7.3 times 10 to the second power is, but they know what 730 is. So I would prefer you not put things in scientific notation needlessly. We only do it to show significant figures, or we do it if a number is too big or too small to go to, you don't want to write all those zeros. So otherwise we won't do it. All right, look at the last problem, number 8. It is on page 75. And in this one, it's a little more complicated. We have grams per cubic centimeter, and we want to change them to kilograms per meters cubed. So 7.21 grams per cubic centimeter equals how many kilograms per cubic meter. So first we write what we know, which is 7.21, and you write grams on top and cubic centimeters on bottom. Now I'm going to show you what I mean. Okay, so this is our question. 7.21 grams per cubic centimeter equals how many kilograms per meters cubed. So we start with writing what we know, but because there's a slash there, we write the grams in the numerator, and that centimeters cubed is in the denominator, so we write it down here. And we pick one of these to convert first, and I'm picking grams. I'm going to change grams to kilograms, so I'm going to put grams in the denominator, kilograms in the numerator, and write the relationship. So grams in the bottom, kilograms on top, and I know there's 1,000 grams is the same thing as 1 kilogram. Now I continue my railroad tracks. And this time I need cubic centimeters up top because I want them to mark out. And I want cubic meters on bottom because that's what I want to change it to. And according to the problem, 10 to the 6 cubic centimeters equals 1 cubic meter. So now grams cancel out, centimeters cubed cancel out, and I'm left with kilograms per cubic meter. Any number on top gets multiplied, any number on bottom gets divided, but you can ignore the ones. The best way to do this is on your calculator, do 7.21 times 10 to the 6 equals, say enter, and then say divided by 1,000. If you don't hit enter in between there, you need to use parentheses, and it gets a little more complicated. So the answer is, not in scientific notation, 7,210 kilograms per meters cubed. 7,210 kilograms per meters cubed. I know that was messy. My marker's kind of dying. I just got these, but they're already dying. They're not staying too long. All right, so that's the chapter. You're going to do the little lab on page 76, and hopefully that helped clear up the math. We will continue with chapter 4, and we'll be getting into a little bit more chemistry. So far, we're just learning basic skills, so we'll be ready to do chemistry. So we're getting there. Hang in there. It's going to be great. Math and science are great. Like, share, subscribe. I have about 250 subscribers, and if I get to 1,000, we don't have to worry about this app crashing all the time because I'll be able to do YouTube Live instead of recording it first. So, goals. My kids say, Mom, it's not going to happen, but I'm already a quarter of the way there, so maybe. Who knows? Anyway, see you next time. Come back for chapter 4, and we'll learn some more chemistry. Math and science are great.